In this video, we're going to be looking at trig derivative rules, the 6 trig functions that we're looking at: sine, cosine, tangent, cotangent, and secant, cosecant. The derivative of sine is cosine, and the derivative of cosine is negative sine. Now, I use these variables u to indicate that for most problems, you're going to be seeing a chain rule portion for each of the trig problems. So for right now, I'm just going to attach u prime to each of the functions to indicate the chain rule portion. So the derivative sine of u is cosine of u times u prime. The derivative cosine of u is negative sine of u times u prime. The derivative tangent of u is secant squared u times u prime. The derivative cotangent of u is negative cosecant squared u times u prime. For secant, the derivative of secant of u tangent of u times u prime. And the derivative for cosecant of u is negative cosecant of u cotangent of u times u prime. Alright, notice the patterns here. Sine and cosine have a similar derivative in the sense that they are each other. Derivative sine is cosine, derivative cosine is negative sine. Tangent and cotangent have similar patterns. The derivative tangent is secant squared u. Derivative cotangent is negative cosecant squared u. And finally, secant and cosecant have similar patterns as well. Secant is secant tangent, and cosecant is negative cosecant cotangent. Another thing to notice is that all the derivatives that start with c are going to end up with all the functions that start with c. Their derivative rules are always going to involve negatives. Now, if we know the derivative for sine and for cosine, then this is enough information for us to arrive at the derivatives for the other 4 remaining trig functions. Alright, so I'm going to show you how we can arrive at these 4 trig functions derivative by simply knowing the derivative of sine and cosine and using chain, product, and quotient rule. So the derivative of tangent, we can think of tangent as sine over cosine. And if we rewrite tangent as sine over cosine, then if we want to find the derivative of sine over cosine, we can approach this using quotient rule. So quotient rule, the derivative is f prime g minus f g prime all over g squared. So the derivative for sine is cosine. The derivative for my g function, my cosine, is the derivative of sine is cosine times the original g function, which is cosine, minus the original f function, sine of x, times the derivative of cosine, which is negative sine of x, all over denominator squared, all over cosine x squared. Now we can combine the terms in the numerator. Cosine times cosine is cosine squared x. The 2 negatives becomes positive. Sine times sine becomes sine squared x. Using Pythagorean identity for cosine and sine, cosine squared plus sine squared is equal to 1. So 1 over cosine squared x, we can rewrite this as secant squared x, which is the rule for the derivative for tangent. Right. Moving on to cotangent. We can also think of cotangent as the quotient of 2 trig functions. Cotangent is cosine over sine. So f prime g minus f g prime, the derivative of cosine is negative sine times the original f function, sine of x, minus the original top function, cosine of x, minus times the derivative of sine, which is cosine of x, all over denominator squared, the sine squared of x. Okay, combine negative sine times sine, negative sine squared x, negative minus cosine squared x, all over sine squared x. Now with the numerator, we can factor out a -1, which means that my inside the parentheses will be sine squared plus cosine squared x, which, like before, we can simplify this to just be 1 using the Pythagorean identity. So we have -1 over sine squared x, which can be reduced to, or simplified to be negative cosecant squared x. Alright, next, secant. We can derive secant by rewriting secant as 1 over cosine of x. Okay, so we can go through quotient rule here, but since there's only a 1 in the numerator, we can rewrite this as cosine of x to the -1. That way we can just resort to using chain rule. So if we want to find the derivative of cosine to the -1, we can go through chain rule, bring down the -1, okay, keep what's inside the parentheses, subtract 1 from the exponent, and then multiply by the inside function's derivative, so cosine becomes negative sine of x. So now we have negative sine of x times -1, which becomes positive sine of x, all over cosine squared x. Cosine squared x can be expanded into cosine x times cosine x. And now we can combine the sine over cosine, make it tangent, times 1 over cosine, and 1 over cosine can be rewritten as secant. So tangent secant can be rewritten in a more conventional pattern, secant times tangent, which is the derivative of secant of x. All right. Finally, we have derivative of cosecant of x, which can be rewritten as 1 over cosecant of x can be written as 1 over sine of x. Again, write this in bring the sine x to the top and make it a -1 as the exponent. Go through chain rule, bring down the -1, keep the parentheses, subtract 1 from the exponent, multiply by the inside function's derivative, so sine becomes cosine of x. Okay. Now the sine of x can be brought down to the denominator. We can expand this, be sine x times sine of x. Okay. Cosine over sine can be rewritten as negative cotangent of x. And then times 1 over sine of x can be thought of as cosecant of x. And the more conventional way of writing the derivative for cosecant of x is just negative cosecant of x times cotangent of x.